Today we're exploring periodic data by looking at periodic functions. Now, a periodic function is a function that repeats a pattern of y values at a regular interval. It's an R. The cycle is one complete pattern before it starts another repetition. And a period is the horizontal length of one of those cycles. Now I'm going to show you what that means. Right here, this is a periodic function. Keeps on repeating the y values as you move left to right. Keeps on going up, then down, up, down, up, down. Through the same y values. One period that they show is the period that starts when you start at the very top vertex, or the maximum we'll call it, going from a maximum to another maximum. And then you see it repeats again, maximum to maximum. It goes through the same y values. So just one of those periods, one of those cycles going from maximum to maximum, has a period. Let's see what the length is. Now, if this is where 1 is, that's probably where 2 is. 3 is probably there. 4, I would say, would be right there where it crosses. There's 5, 6 maybe, 7, I'd say 8 would be right there, 9, 10, 11, 12, 13, 14, and so forth. Okay, that's on the x-axis. Now, what we see is that the period that we shaded in goes from 2 to 6. The period is that distance between 2 and 6. So all you have to do is subtract those two numbers, and you get a period of 4. Another period that they're showing us is going from one x-intercept to another. So here's an x-intercept right here, and then this is another one. We skipped over this x-intercept because what you see is that as it approaches this x-intercept, it's going downward, and as it approaches this one, it's going up. So we have to go to the other one where it approaches the x-intercept going upward. Going from this x-intercept to this x-intercept, not worried about that one. The distance would be from 8 to 12. The difference between 8 and 12 is 4. No matter which period or which cycle you choose to draw out, it should have the same period. That is what makes a periodic function. Analyze the periodic function. Identify one cycle in two different ways. So basically two different ways of the cycles. We can go from maximum to max, or from x-intercept to x-intercept. And then we want to determine the period, or the length of a cycle of the function. So the first way we did it before was going from a maximum to a maximum. Let's do that. Draw that in. And if that's where 1 is, that's where 2 is, 3, 4, -1, -2, -3. What we see is that the period goes from -3 to +1. the difference, if you take 1 minus -3, that equals 4. So your period should be 4. Now let's do it the other way. What if we start at an x-intercept, and this is where it approaches from the bottom, go through, skip this one, this x-intercept right here, because it approaches from the top, keep going to this x-intercept right here, because it approaches from the bottom. That period would start at 0 and end at 4, which has a distance of 4. Determine whether each function is or is not periodic, and if it is, find the period. Does this go through the same exact y values every single time? No. It gets lower and lower and lower. They have to be the exact same. So as it goes down, no. If it had stayed like this, that would be periodic, because it goes through the same values. So that's a big no. Determine whether it's or not it's periodic, and if it is, find the period. Does it look like it's going through the same y values? It sure does. It looks like if we start at this maximum, goes down, goes up, slows down, then goes up again. That looks like one cycle, and then it looks like you could go through another one, and I'm guessing it would go like this. If we needed to, we keep on drawing. Now, the length of one of those cycles goes from 0 to, well, if that's 4 and that's 8, that would probably be 10. So this would probably be 9. From 0 to 9, which means it has a period of 9. And yes, it is periodic. Is this periodic? And if so, find the period. Sure looks like it. Now let's find the distance between one maximum to another maximum. We could also go from a minimum to a minimum. But we see that this maximum occurs at -2, this maximum occurs at +2. So we're going from -2 to +2. The distance between those, or 2 minus -2, is equal to 4. So yes, and period equals 4. Is this periodic? No, because it doesn't go through the same y values. It goes up over time. For it to be periodic, it would not go up or down over time. It would be horizontal. So no. Amplitude is equal to 1/2 the difference between the maximum y and minimum y value. Now, if we wanted to find the amplitude of this, what you pretend is that you have drawn a line right through the middle, sideways through the middle of a periodic function. And then what we're asking is to get from the middle to the minimum, what is that distance? It should be the same distance as from that middle line that you drew to the maximum, or the very top of the periodic function. Now let's look at this. If this is where 2 is, that would be where 1 is, 0, -1, and then 3. 1, 0. What we see is that the maximum, the very top peak of one of these curves, is at a y value of 3. The very bottom peak, or valley I should say, is at a y value of -1. So that would be the maximum and the minimum. The difference between 3 and -1, well, you could subtract them, is 4. Half that distance, or difference, is 2. So what you should see is that 2 is the distance from that imaginary middle line to the top, and then that imaginary middle line to the bottom. That is your amplitude. Find the amplitude of this periodic function. What we see is that the max is at 4. The minimum, I should say y equals 4. The minimum is at y equals -2. Four minus -2 equals 6. That is the difference. Half of that is 3. That is your amplitude. Imagine that you drew that imaginary line sideways. So the distance from that imaginary middle line to the top would be 3. Same thing, that imaginary middle line to the bottom would also be 3. That's what amplitude means. Find the amplitude of this. Okay, so if this is where -2 is, this would probably be -1, 0, probably 1. What we see is that the max is at y equals 1. The minimum is at y equals -2. The distance between y equals 1 and y equals -2 is 1 minus -2, which equals 3. Half that is equal to 1.5. Find the amplitude of this. So if this is where 4 is, four is right here. This would probably be 2. This would probably be 3, 1, 0. So the max is at 3, or y equals 3. The minimum is at y equals 0. The distance, or difference, equals 3. Divide that by 2. You get an amplitude of 1.5. And that's it. This is your homework. Make sure you do it, and I'll see you guys the next day.